Recent studies have highlighted gaps in global AMR surveillance. And so whilst you have initiatives that do exist to tackle these gaps, like WHO GLASS, these are still actually quite limited. So you can see that in the infographic we've put in our report. So the map on the top left here shows the coverage of the publicly available subset of GLASS. So the first thing to note there is I said publicly available subset because actually, to the best of our knowledge, only a subset of GLASS is publicly available, which is an obvious first limitation. But then more importantly, you can see there's still quite a lot of coverage gaps on this map. Now, when we saw this, we thought, well, actually, can't we use industry surveillance datasets to substantially improve this coverage? So that's the map on the right, where we show the coverage for all these different data sets together. And you can see, obviously, there's a lot more color on the right than on the left. And also, you're going to increase your coverage in terms of bacteria, antibiotics, and years. So how do we use these industry datasets to fill in global AMR surveillance gaps? So for this, we provide a pipeline in R to harmonize and combine these datasets, and also provide a comparison between resistance rates from industry surveillance datasets and GLASS. So I'm going to show you that in R right there. So this is the script which takes these different datasets and combines them for a combination of years, bacteria, and antibiotics of interest. Now, while this runs, I'm going to go back over to the presentation. Because actually, when we designed this pipeline, the very first step that we had to do was to check that, does it make sense to combine these different surveillance datasets? So we conducted an extensive methodology analysis of these different surveillance programs, how they sampled isolates, how they conducted their microbiology testing. And we found that overall the methods were quite similar, which was quite reassuring, although there was the need to clarify criteria surrounding isolate collection. So as I said, once we've got all of this harmonized and combined, then here we propose a comparison with resistance rates you can find in that publicly available subset of GLASS. So I'm going to go back over to R now. You can see the script has finished running. It gives you a little summary at the end of where it found your combination of interest. And more importantly, it generated this combined data set and saved it on your computer, so you can reuse this for whichever analysis you are interested in. So this compared the resistance rates in all the industry surveillance datasets to the resistance rates in GLASS. Now, each point here is a comparison by year, country, bacteria, and antibiotic. So if all the points were along the line, then that would mean the resistance rates are similar. That's what we saw in our report for E. coli and Klebsiella pneumonia. So here you can see that's the case for colistin resistance and for some higher resistance rates. But what looks like it's happening here is that you've got slightly higher resistance rates in the industry data sets here than GLASS. Now, that doesn't mean that one is right and the other is wrong. This is just us highlighting that these differences exist between the data sets and must be taken into consideration by people who are interested in looking at these different data sets for any sort of work. So to sum things up, in terms of innovation, here we propose the first large-scale temporal comparison and combination of surveillance systems. And this highlights that industry surveillance datasets can fill in global AMR surveillance gaps. They have comparable surveillance methodologies, although we do highlight the need for greater clarity around isolate collection criteria. We do find some limitations of GLASS. And then in terms of generalizability, so our novel pipeline, as I've shown you, can generate years, bacteria, antibiotics combination resistance data. The pipeline is freely available, open source on GitHub. And then finally, in terms of impact, basically this provides reliable data for future research. So any work such as trend analysis, burden estimates, machine learning approaches which require this type of AMR data is basically substantially enhanced by this approach, which makes the most of what's available, but also provides a comparison framework with other data sets.